Line drop example. In this presentation, we're going to go through an example of a typical line drop question and do a few of the calculations associated with it. Let's get going. What we're going to be specifically answering would be, how do I calculate percent line drop? How do I calculate the line drop value that's total? And how do I then calculate the load voltage? Well, let's apply all of these to a question. And the question that we're going to have is a 240 volt source connected through two 0.5 ohm individual conductors. There's two of them, obviously, all the way over to a load. And let's give that load a current value. I'm going to say this load is 15 amps. Now, the first thing I want to do is calculate what the line drop is across each one of the conductors. And in order to do that, I need to know that 15 amps is flowing throughout the circuit because, well, this is a series connection, isn't it? So 15 amps is flowing through each of the conductors. And if I want to calculate the voltage that would be present across each conductor, I need to use Ohm's law. Ohm's law dictates that E is equal to I times R. So if I take the current value of my load, which is 15 amps, and I multiply it by the resistance, which is 0.5, 15 times 0.5 gives me 7.5 volts. Now I really only have to do that calculation once because both conductors are identical in value and the current value that's flowing through them is identical as well. So we can then say that 7.5 volts must be dropped across each conductor. Now remember, when we're talking about voltages in a closed loop, like what we have here, we can use Kirchhoff's voltage law because 240 volts would be the total voltage rise, and the voltage drops in the loop must equal the rise. Right now, I have 240 rise and 7.5 drop and 7.5 drop. That means that for me to calculate the voltage across my load, I'm going to be taking 240 volts. I'm going to do it over here. 240 volts minus 7.5 volts minus 7.5 volts. What this should give me is the voltage across the load. So 240 minus 7.5 minus 7.5 gives me a total of 225. So 225 would be the voltage across my load. So let's put that here, 225 volts. All right, so now that we got 225 volts across the load, let's calculate some of the other items that were asked for. So first, what's the total line drop? Well, the total line drop is all of the conductor line drops added together. So total line drop would be equivalent to both of those added, right? 7.5 times 2, which gives me 15 volts. So this would be the total line drop. Now the last question is, what is the percent line drop? Well, the percent line drop is a calculation that is based on the total line drop divided by the source. So I'm going to say total line drop divided by source voltage. Now, of course, you're going to have to multiply it by 100 after, because after we multiply it by 100, that should give us our percent line drop. So with this particular question then, what we have is 15 over 240. So 15 volts divided by 240 volts gives me 0.0625. So 0.0625. And I want that in a percent, right? I need that in a percent. So really multiply by, well, not by 100. Sorry, that's my mistake. Shouldn't be by 100. That's not percent. I'm going to multiply it by 1, 2, oh no, it is. Geez, I'm losing my mind here. All right, so multiply by 100, 1, 2, moves the decimal place over. That is 6.25% line drop. Whew. All right, so that's how we go about calculating percent line drop, as well as calculating what the total voltage is that's dropped on the conductors and the load voltage.